Our next speaker is Suneva Collins, Professor of Mechanical and Aerospace Engineering.
Thank you all for coming. And I know that many of you, I told you you had to be here, so I'm really glad to see those of you that are here. I have a slightly different point of view on standards because actually I lived and worked with standards for 18 years when I was at Swagelok. So I try and bring that into the classroom. I teach design and manufacturing, and many of you have had me for those courses, so you know that I bring up standards as something that are very important in the ability to manufacture a product or a process or a service and then be able to sell it in the marketplace. Because if we don't meet the minimum requirements of standards, quite often what happens is there's not an opportunity to be able to sell because it doesn't meet those safety requirements that are out there. So I'm going to move forward on this. So let me just talk about my experience with standards at Swagelok and why I bring this up as an important aspect in the teaching that I do. Swagelok, for those of you that don't know, it's among the top private companies in the United States. It would be in the Fortune 500 if it were a publicly held company. Currently, it has about $2 billion in sales and over 3,000 associates worldwide. It does manufacturing, distribution, and technical work all over the world, and it serves a lot of different markets: oil and gas, semiconductor, analytical markets, chemical markets. So basically a wide variety of places where the Swagelok tube fitting is used. Now, I don't know if there's a laser on this, is there? All right, I don't want to point this in somebody's eyes, so I'm going to let Brad figure it out first. Okay, Swagelok's major product is this tube fitting. How many of you have used a Swagelok tube fitting? Okay, what's interesting about the Swagelok tube fitting is that it looks like any other tube fitting that's out there. There are actually 28 other copy lock companies around the world that sell counterfeit Swagelok devices. What makes this one unusual is every single component in this is marked. It has a heat code on it. And the reason it has a heat code is for traceability, which means that if you have a Swagelok tube fitting and you know what the heat codes are, they actually have the paperwork and the standards to backtrack and figure out when that part was made, what material it was made from, all the way back to the melt of material and the steel mill that it came from. Now, why do you think that might be important? It's important because it's a requirement if you're going to sell into the nuclear industry. It's important because it's a requirement if you're going to sell to the Department of Defense, because they want to make sure that the metal that gets used in products that go onto military hardware comes from friendly countries. So all of this, it's actually kind of built into their system. So one of the things that I learned early on was that I really needed to learn about standards and how they affected the product and the ability to sell the product into different markets. The other thing about the Swagelok tube fitting is, you know, I think there's 5 different components to it, and there's actually an awful lot of engineering in it. I'll talk about that at another time. But basically, when I was there, I had a lot of different interesting interactions with standards, and I'm going to go over that on the next slide. One of my first positions at Swagelok was as a research metallurgist, and I got involved in standards development. I was one of the people that they sent to standards development meetings in order to represent the interests of the company, but then also of the industries that were being served. And basically that was when I got involved in the semi-standards development. And semi-standards are the Semiconductor Equipment Manufacturers International. I basically ran several committees for them on things like raw materials for use in making semiconductor equipment. I put together the groups that developed the welding and inspection standards for that industry. And believe me, that was like herding cats. It really was. I mean, we had everybody with an opinion on how it ought to be done, and a lot of it was with this idea of how do we come up with a minimum acceptable standard that everybody can agree to. And even at that point, there were people that dissented, so we had a lot of discussion. But as you can tell from the other speakers today, there are several steps that any standard goes through in its development, and the point is to make sure that it really is industry consensus that finally comes out. One story, I was working on the stainless steel standard for the use in semiconductor equipment, and we were dealing with people from all of the steel manufacturers. The Japanese contingent was very interested in making sure that we used a particular grade that was called a low manganese grade that was specifically being manufactured for semiconductor applications. And we came very close to having a standard developed on it. And the week before we were going to vote on it, the patent came out for Sumitomo that they were patenting that material. And so basically, you know, back to start, we threw it out, because once you have a patent on a material like that and there's only one person that can make it, that's essentially the same as setting up a monopoly. So there's a perfect example of this whole idea that you basically have, this has to be open and it has to be industry consensus. I also worked as the manager of materials technology at Swagelok, and basically I had a staff of scientists and engineers that worked for me. We had corporate responsibility for maintaining our material specifications. And you know, you think a company like Swagelok only makes certain things, right? We had over 200 material specifications, and they were all based on standards that would give us basically a minimum accountable requirement. So we got very familiar with ASTM A479, you know, that, because that was the basis for our specification. I know there was a question earlier that Libby had about materials specifications and proprietary standards. Companies do this, first of all, because it gives them a purchasing opportunity, a purchasing requirement. They can actually get rid of a lot of problems in their performance of making product if they can specify their material very, very tightly. So that's part of the reason for that. So it's a purchasing specification that then allows you to avoid problems in your manufacturing if you have these types of material specifications. But they really do have to depend on the underlying standards that are used to write those. I did so well in materials technology that they decided to take me out of it. And my vice president of engineering came to me once, and he's like, "Okay, Collins, I need you in compliance." And I went home and I cried because I said, I'm not sure I can handle just doing standards, right? Well, part of it too was it was my first move away or out of materials, and I really didn't want to get too far removed from that. But I ended up being manager of regulatory compliance. It turns out that that is, for a company like Swagelok, considered to be a market advantage to have a group that actually works on that. Because what that meant was that we were ensuring the product and regulatory compliance to a whole variety of standards, not just in the United States, but also in other parts of the world, and making sure that we could sell into different markets. Sometimes it's things like being able to specify that you can get to a certain temperature range, and all of a sudden an entire market opens up. Or you have the certifications that say that, yes, we comply with these particular requirements, and then you can sell there, whereas your competitor may not be able to. Now, you'll notice that I said here you've got 30 associates. So basically, we had a lot going on with that. So you can see that's a full-time job for 30 people for a company the size of Swagelok. I was also working on sponsored research projects. So was the principal investigator, and basically we had standard materials and test methods for reproducibility. So when I put together my test plans for my research, I was using ASTM test methods and standards so that basically we could reproduce the data. And I have one more slide that I'd like to show. I know, I'm over time, right? This basically is to give you an idea of what standards can do. On the left, we have basically the different sizes of chips and of wafers that were available. And when I started working at Swagelok, I think it was the 200 millimeter was the standard, and we were working toward a 300 millimeter and then to a 400 millimeter. So basically getting larger and larger wafers. Secondly, on the other side, you'll see this graph that shows feature size that's capable. And if you start up at the top here and take a look at, say, 1995, which was about the time I started working at Swagelok, 350 nanometers was the size of the feature that you could get onto a chip. By the time I left Swagelok in 2013, we were down to 16 nanometers. I can tell you that this sort of evolution of feature size and then also the ability to make more of the same thing in, so larger quantities and smaller dimensions only happens because of people applying and using standards. So this is all about the idea of how do we meet a market. We have to make sure that we bring these improvements in by making sure that we've got the right standards in place. So that's just a quick overview of my experience with standards, and I'm happy to hand it over to somebody else to talk about now. Thank you.